This video is about testing for metal ions, or testing for cations. Now, we can use flame tests for some metal ions, but in this test, we're going to use sodium hydroxide solution and ammonia solution. It's important that you use the word solution and don't just say sodium hydroxide or ammonia. So sodium hydroxide solution is the first one I'm going to do, and I'm going to add it to these 6 solutions. This one contains zinc 2 ions. This one contains aluminium ions. This one is magnesium ions. Then we've got iron 2, iron 3. This is Fe2+, Fe3+, and then this solution contains copper 2 ions, Cu2+. What I'm going to do is just add a few drops of sodium hydroxide solution to each of these, and we'll observe what happens. First of all, add it to the solution containing the zinc ions. You should be able to see that there's a precipitate forming here. So we say a white precipitate, and a precipitate is a solid that forms in a solution during a reaction. It's basically a solid. Now, if I continue adding the sodium hydroxide until it's in excess, so at the minute I've just added a few drops and I get a white precipitate. If I keep on adding it, we'll see if anything happens to it. So just put in a few dropper fills, and then I'm going to give it a stir with a stirring rod. And hopefully you're able to see the solid is starting to disappear. It's starting to dissolve. Just put in a few more dropper fills of the sodium hydroxide solution. And there you can see the precipitate has dissolved. So zinc ions, when they're in solution and sodium hydroxide solution is added to it, it forms a white precipitate which dissolves in excess sodium hydroxide solution to give this colorless solution. Okay, now I'm going to do the same thing with the solution containing aluminium ions. I'll add a few drops. And you should be able to see, again, we're getting a white precipitate. I'm going to do the same thing as I did with the zinc solution. I'm going to add sodium hydroxide solution until it's in excess. Now you can see right away what has happened there. The white precipitate has dissolved. So these 2 solutions have given the same result, the zinc solution and the aluminium solution. White precipitate forms, which dissolves in addition of excess sodium hydroxide solution. Okay, we'll move on now to the solution containing magnesium ions. Again, a few drops of sodium hydroxide solution are added to it, and you can see that it's a white precipitate. Now let's see what happens this time when I add the sodium hydroxide in excess. Just give that a stir. Add some more. Now that doesn't look as though it's doing anything. So it forms a white precipitate initially, just like these 2. But the precipitate does not dissolve in excess sodium hydroxide solution. So that's how we distinguish the magnesium ions from the zinc and the aluminium ions in solution. Now, of course, this method cannot be used to distinguish between zinc a solution containing zinc ions and a solution containing aluminium ions, because they both give the same result. However, we can identify the magnesium ions and distinguish it from these two. So I'm just going to then continue this part of the experiment by adding sodium hydroxide solution to an iron 2 solution, and this time we get a green precipitate. I know it looks very dark, almost like black, but it's a green precipitate. Which does not dissolve in excess. You can see that it's not dissolving at all. And now iron 3. You see now we've got a brown precipitate. It looks like rust. And indeed, rust is hydrated iron 3 oxide. So this solution contains iron 3. It's a brown precipitate. And in excess, the precipitate is not dissolving. There's no change there. The last one, then I'm going to add it to the copper 2 solution. You can see that we're getting a blue precipitate. And if I place a piece of white paper behind that, you might be able to see it better. Maybe not, but it's a blue precipitate there. And if I added an excess, again, nothing seems to be happening. The precipitate does not dissolve. So what you have to be able to do in answering these questions is describe or state what happens whenever a few drops of the sodium hydroxide solution are added to it, and then state what happens to the precipitate when excess sodium hydroxide is added to it. So in this example here, we would say blue precipitate forms, which does not dissolve in excess sodium hydroxide solution. Whereas, for example, for the aluminium ions, you would say a white precipitate forms, which dissolves in excess sodium hydroxide solution. Now, a bit later on, I will go over and explain in more detail what these precipitates are, but they're all hydroxides. Sodium hydroxide solution produces OH- ions, and when the magnesium ions react with the hydroxide ions, they form this precipitate. So this here is magnesium hydroxide. The green precipitate in here, remember this is a solution of iron 2, so this here would be iron 2 hydroxide. This would be iron 3 hydroxide, and this is copper hydroxide, and that's what the precipitate is. Now we can also use ammonia solution. Get some fresh solutions. I'm going to do the same thing, only this time I'm going to add ammonia solution. And I'll start off with the solution containing zinc ions. I add a few drops. And you can see that a white precipitate forms. And if I keep adding this until the ammonia solution is in excess, we will see a change occurring. And I'll just give this a bit of a stir. And you should be able to see there that that white precipitate is dissolving. So it's almost gone. There's still a few bits of the white precipitate there. But if I added some more ammonia solution, they would all disappear and dissolve. So the solution containing zinc ions produces the same reaction in both cases. You get a white precipitate initially, and then the precipitate dissolves in excess solution. Okay, so I'm going to do then the same thing with the aluminium ions. Now again, you can see, okay, this is going cloudy. So again, we're getting a white precipitate. Now, I just add. Now again, it's very difficult for you to see here. Just adding some more ammonia to try and get you to come across the screen a bit better. So we've got a white precipitate here. It's not really dissolving in the excess ammonia solution. Again, the same result initially, white precipitate, but this time it does not dissolve in excess ammonia solution. If I then add it to the magnesium, and I'll just wait there a few seconds, you can see we've eventually got a white precipitate forming. And it does not dissolve in excess. So that's just the same result as when I used sodium hydroxide solution. Okay, I'll add it to iron 2, and we get a green precipitate, just exactly the same as before. And that does not dissolve in excess. Again, I'll just add ammonia solution to iron 3. And like before, we get a brown precipitate. That does not dissolve in excess. And lastly, add it to the copper 2. And you can see it's a blue precipitate. So that's just like before, but you should notice difference when I add excess ammonia solution. Ooh, and you can see there that the precipitate is almost dissolved to a deep blue solution. Just add another dropper full of ammonia solution to it. So that's different this time. So initially it's the same as the sodium hydroxide solution. You get a blue precipitate, but when excess ammonia solution is added to it, the blue precipitate dissolves to form a deep blue solution. And again, you have to know the names of all of the precipitates that formed initially. And they're just exactly the same as with sodium hydroxide solution, because ammonia solution contains hydroxide ions as well. It's a weak alkali. And so the white precipitate for all of these, for example, here is the magnesium solution. That white precipitate is magnesium hydroxide. This green precipitate is iron 2 hydroxide, iron 3 hydroxide. The initial blue precipitate here was copper 2 hydroxide. So the ionic equations that you have to be able to write for both of these are exactly the same. And I'll go over those in another video. So in this video, I'm going to look at how the precipitates form, or why they form whenever sodium hydroxide solution or ammonia solution are added to metal ion solutions. So if we look at sodium hydroxide solution being added to a solution that contains zinc ions. So I'll just write AQ. This is aqueous sodium hydroxide, which is obviously sodium hydroxide solution. And the solution part, or the aqueous, is important. Now, when sodium hydroxide solution is added to a solution containing zinc 2 ions, a white precipitate is formed, which dissolves in excess sodium hydroxide solution. Now, I'm just going to go over why the white precipitate forms. So if we've got our zinc ions, they react with the hydroxide ions that are in the solution. Sodium hydroxide fully dissociates in water to form sodium ions and hydroxide ions. It's a strong alkali. And it's these hydroxide ions that then react with the metal ion. And when they react, it forms a metal hydroxide in each case. So in this example, it's going to be zinc hydroxide. Now I need to balance the equation, so I put it 2 in front of the OH minus. So this is the white precipitate. And it's basically the same, or it's a very similar then ionic equation for the formation of the precipitates in all of the other examples. Let's do the next one. Aluminium. If sodium hydroxide solution is added to it, so I've got aluminium ions in solution. They're going to react with hydroxide ions to form aluminium hydroxide. That's a white precipitate. Again, need to balance it. And in this case, the white precipitate is aluminium hydroxide, and that dissolves in excess sodium hydroxide solution. With the magnesium ions, it would form a white precipitate of magnesium hydroxide. And in this case, the white precipitate does not dissolve in excess. With the copper 2 ions, well, we would have copper 2 reacts with hydroxide ions to give copper hydroxide. That's the blue precipitate. And you do the same sort of thing then with the iron 2 and iron 3. I'll just skip out the iron 2, I'll go into the iron 3. So you've got iron 3 reacts with hydroxide to give a brown precipitate of iron 3 hydroxide, and that's the name of this. It's iron 3 hydroxide. You don't just say iron hydroxide, because you can obviously have iron 2 hydroxide. Okay, we need to balance that, so we'll put a 3 in front of it. Now I'll look at what happens when ammonia solution is added to these metal ion solutions. So this is ammonia solution, or aqueous ammonia. Now, when ammonia is in water, when it's a solution, it forms ammonium hydroxide. So ammonium hydroxide is ammonia solution, but we normally just say ammonia solution or aqueous ammonia. Now this is a weak alkali because the ammonium hydroxide splits or partially ionizes in water. That's why it's a weak alkali, and it partially ionizes into ammonium ions and hydroxide ions. So again, you can see that hydroxide ions are formed, and a lot of the reactions are similar, and indeed the ionic equations are exactly the same as they are for sodium hydroxide solution. Now when the ammonia solution is added to the zinc ion solution, you get a white precipitate. And that is because the zinc ions react with the hydroxide ions to form zinc hydroxide, the white precipitate. And that precipitate dissolves if you add excess ammonia. If you add it to the aluminium ion solution, then the aluminium ions will react with hydroxide ions to form aluminium hydroxide. That's the white precipitate, and that does not dissolve in excess. So I need to put a 2 there. The magnesium ions, then they form a white precipitate of magnesium hydroxide, which is insoluble in excess. The copper ion solution will react with the hydroxide ions to form a blue precipitate of copper 2 hydroxide, and that blue precipitate will dissolve in excess ammonia solution to give a deep blue solution. You don't need to know the equation for the formation of that blue solution. Iron 2 will react to give iron 2 hydroxide, just exactly the same as what happens when sodium hydroxide solution is added. And then I'll do iron 3 reacting with the ammonia solution. Again, it just reacts with the OH minus ions to form iron 3 hydroxide, which is a brown precipitate. Again, we'll put a 3 in front of that in order to balance the ionic equation.